In this video, I'm going to teach you how to use Cloud Firestore as the database of your Flutter app. So Cloud Firestore is NoSQL database, so the way to store data is a little different than relational databases. So first of all, I'll show you how data are stored in Firestore, and then I'll show you how to fetch those data from Cloud Firestore and how to add a new data to the Firestore database. For this tutorial, I have created a new Flutter project and I have added Firebase to it. So if you have not added Firebase to your Flutter project yet, then you have to do that first. And for that, I have another video. I'll put the link in the description. You can check that and you can add Firebase to your app. And now, let us take a look at the Firebase project. And here is the page for the Firebase app, for the Firebase project. Now on this page you will find this option Firestore database. Click on it and then you will find the page for Cloud Firestore and click on this button, create database. Now here we have two options. One is start in production mode and another is start in test mode. So if you select this start in test mode, then anyone will be able to read and write items to this database. This is not at all secure. And if you start with this option production mode, then there will be a restriction. No one will be able to read and write anything on this database. We shall start in this mode, production mode, and we shall see what error we get. We won't be able to access the data and we shall get permission denied kind of an error. And then we shall change the security rules to allow only the authenticated users to access the database. Then select Cloud Firestore location. I'm going to keep it the default one and then click on this button, enable. Now consider that we are going to create a shopping list application. So once the user logs in, the home page will appear, and on the home page we shall display a button, a floating action button, to add a new item to the shopping list. And on the page, on the home page itself, we shall display the items of the shopping list. So here is the Cloud Firestore database. At this moment we have nothing here. You'll find this button, start collection. So the unit of storage in Cloud Firestore is called a document. So in our case, we are going to store items of a shopping list, right? Let's consider each item. Let's name each item of the shopping list as shopping item. So we are going to store lots of shopping items on our database. So we have to represent in the individual shopping items by a document. A document have multiple properties. In our case, it will be the name of the item, then the quantity of item, etc. And we have to organize these different documents inside a collection. So we have to create a collection, and then a particular collection will contain multiple documents. So in our case, we shall create a collection. Let's name it shopping list. And if you create the collection from this interface, then you will be asked to add the first document. So here we have this form to add a new document. Let us add a simple document, a simple shopping item. So here you will find this field called document ID. You can add a custom document ID here, but you can also add a auto-generated ID, and this is the best option in this case. So we are going to auto-generate a ID, and then we are going to add the fields of the document. So in our case, a document is going to represent one shopping item, right? So we are going to add a field named name, the name of the item. So for this case, let's add milk. So let's add another field for quantity, and here let us add 1 liter as the value. Now let's save this one. And here you will notice that our collection has been created named shopping list, and we have one document inside this collection. And the document, if you click on it, you will find the information contained inside this document. So we have a name and a quantity. So you can keep on adding different properties for the document depending on the type of data that you are going to store. And here we can keep on adding multiple documents here. We are going to do that, but from the app. Now let us open Android Studio, and here is our app at this state, at the current state. So I have added Firebase to the Flutter app, to the Flutter project, and I have also implemented authentication. Now if you have not added Firebase yet, then you should do that first. For that I have another video, you can find the link below. Watch that and add Firebase to your Flutter project. And I have implemented authentication, but that is not compulsory. If you don't want to implement authentication now, don't worry, you don't need to do that. We are simply going to fetch the data from our database and we shall display them on this page, on the home page. So we have already seen how data are stored in the Firestore database, right? And at this moment we have only one item there, only one shopping item, and we shall try to fetch that and display on this page as a list. Now to be able to communicate with the Firestore database, we have to add a plugin called Cloud Firestore. So open the terminal in Android Studio and run the command. In Android Studio, or you can use any terminal, you have to go to the directory of your project, of your Flutter project, and you have to run the command flutter pub add and then the name of the plugin. So in this case it is cloud_firestore. Press enter. Now this plugin has been installed on your project, and now we can start accessing the functions, APIs of this package, this plugin. So here we have to import the package cloudfirestore.dart, and now we can start calling the different functions, accessing the different classes of this package. So here we have the widget my home page, responsible for the page that we have now. And the state class is this one, my homepage state, and here we have this build function which is responsible for creating this layout. We have a scaffold, we have an app bar. On the app bar we have the title and this logout button here, and we have the body, and on the body we have the widget center at the root, and then we have a column. Inside column we have two text widgets. We are going to remove this widget tree completely, so we are going to remove this, and here we are going to add the widget to display the list of shopping items from the Firestore database. But before that, we have to get a reference of the collection that we have there on our database, and then we have to use the functions of the collection to access the documents that are inside that collection. So first of all, here inside this state class, create an instance, create a field of type collection reference. So this class belongs to the package Cloud Firestore, and let's name it reference shopping list. We have to get an instance of the class Firebase Firestore by calling Firebase Firestore.instance, and then we have to call a function named collection. So this function will give us an instance of collection reference corresponding to the collection that we specify here. So the name of our collection is shopping_list, right? Let's verify once. Let's go back to Android Studio, and here while calling the function collection of the Firebase Firestore instance, we have to pass the name exactly as we have specified it there. So it should be shopping list. Now with the help of this collection reference, we can get the list of documents that are inside the corresponding collection. And there are two main ways to get the list of documents. We can call the function get on this instance of collection reference, and this will give us a future. The future will contain the list of items. We will be able to get the list of documents of the collection inside that future. But there is another way, and that is by calling the function snapshot on the same collection reference instance. And this function snapshot returns a stream, and from that stream we can get the list of documents. So what is the difference? Difference is we can listen to a stream, but we cannot listen to a future. So if we use this stream, we will be able to listen to the real-time updates on our collection. So if we add a new item, for example, let's consider that we also have a corresponding website for our shopping list app, and if you have the app opened and if you add an item through the website, the database will be updated. A new item will be added to the collection shopping list, right? And that change will be immediately reflected on our app. We will be able to listen to the changes, and immediately, according to the changes, we can make changes to our app. So the difference between snapshot and get is that get returns a future, snapshot returns a stream. We can listen to a stream. Stream is an active connection between the two ends, the source of information and the consumer of information. In this case, the source is Firebase and the consumer is our app. So we can listen to a stream to get real-time updates, but using future we cannot get real-time updates. So in this case, let us use the stream. There is a widget called StreamBuilder which helps us in displaying data from a stream. So if you have ever used Future Builder, this is going to be same. So instead of future, we have to provide a stream to StreamBuilder, and the syntax is almost the same. So here we are going to replace the current widget tree of our body, of the body of this widget. So we have this widget center, and inside we have a column. Inside the column we have two text widgets, right? We are going to remove this, and here we are going to add a StreamBuilder. While creating the instance of StreamBuilder, we have to provide values for two of the properties. First is the stream, so we have to provide the stream to which we are going to listen and we shall get the data. And then we have to provide an implementation of a function to this property builder. Inside this function, we are going to create the layout depending on the data. So in this case, we are going to provide a stream, the stream from which we shall get the list of shopping items from our database. And inside the builder function, we are going to check if any error has occurred, then we shall display some errors. While getting the data, we shall display a loader, and when we get the data, then we shall display a list. So we shall use a list view inside this function to display the list of shopping items. Now let us provide the value for this property stream. So where do we get this stream? As I have shown you just now, we have to get the stream by calling the function snapshot on the collection reference. But making a call to the function here inside this widget here itself is not a good idea, because we are inside a build function. This may get called multiple times, and every time this gets executed, we are going to call this function, which is not a good idea. So the better approach is to make a call to this function inside the init state callback function. So here let's add init state, add the init state callback, and here we are going to call reference shopping list dot snapshot to get a stream, and we have to create a field to hold this stream. So let us create a stream, a field of type stream, and here we are going to let's name it stream shopping items. We shall assign the result of calling snapshots on the collection reference to this variable stream shopping items. Now we also have to specify the type here, type of the item that we are expecting from the stream. So what exactly we are expecting from this stream? Let's take a look at this function definition. Click on it by pressing Ctrl. So if you keep on pressing the Ctrl key and then you click on a function or a class, then you will be taken to the source code. So here we can see that we can see the return type of this function snapshot. So it returns a stream of type query snapshot. So we will be able to get the documents of the collection from this query snapshot. So let's specify the type to be query snapshot here, and we also have to specify the same type here while adding the StreamBuilder. Now we still have the error here because of null safety. We have to either make it nullable or use the keyword late to inform the IDE that we are going to initialize it soon, even before we start using it. So now I have added the keyword late and the error has gone. Now we have to pass this stream to the property stream of the StreamBuilder. And now let us provide the value for this property builder. This is going to be a function, and this function will get two arguments. One is a build context and another is an instance of a class called async snapshot. So we shall get the data inside this instance. This class has a property called data, which gives us the data that we are looking for. So in this case, snapshot.data will give us an instance of query snapshot if no error occurs then. And from the query snapshot, we can get the list of document of the corresponding collection. So inside this function, first of all, we are going to check if any error has occurred. For that, add an if statement, and here we are going to check if snapshot.hasError is true. So if it is true, this means that some error has occurred. Then we are going to return a text widget containing the error message. This instance snapshot has a property called error, from which we can get some information about the error itself. So let's pass snapshot.error.toString to this text widget, and we shall return it from this function. So the widget that we return from this builder function will be added to the body of the scaffold. Let's wrap it by center to display the text at this center. Then we shall check if the connection state of the stream is active. So this instance snapshot has a property called connection state. We shall check if snapshot.connection state is equal to connection state dot active. Then only we are going to try to fetch the data that we are looking for. If none of them are true, then we are going to display a loader. So we shall return an instance of circular progress indicator. We shall wrap this by the widget center to display this at the center of the page. Now inside this block, we shall try to get the data. So the data that we are looking for is an instance of a query snapshot. So let's create a variable of type query snapshot and assign snapshot.data to this variable. And here we have got an error. Now if you take a look at the console, you will find some information about the error, and here you will find this message: minimum SDK version 16 cannot be smaller than the version 19 declared in the library Cloud Firestore. So we are using this package Cloud Firestore, right? In the Cloud Firestore, the minimum SDK version for Android is specified as 19, but in our project it is specified as 16. So this has been specified by default. We are going to change it and we shall make it 19. So here you will find this directory Android, and here you will find this directory named app. Inside you will find a file named build.gradle. So here find this section named default config, and here you will find this property called minimum SDK version, and here this is being provided flutter.minimum SDK version. This is kept somewhere as a variable and it is being accessed from this file. So instead of this, we are going to pass 19 directly. Now save this and let us try to run the app again. Now here we have got an interesting error, and this one is important because it is almost sure that you are going to face this issue when you use Firebase. So the code that we write are converted to bytecode to be executed in Android. These bytecodes are stored in DEX files, where DEX stands for Dalvik executables, and there is a restriction on the number of function references that can be kept in a single DEX file. A single DEX file cannot contain more than 65,536 function references, which is 64 into 1024. So this number of function references is not only the functions that you write in your code, it also includes the function references in the code of the framework and all other third-party libraries that you depend on, and your own code. Including all of this code, If the number of function references exceeds this number 65,536, then you need to enable multi-dex, enable the support for multi-dex. And if the minimum SDK version supported by your app is 21 or above, then this is enabled by default. If it is below 21, then you have to explicitly enable the support for multi-dex. So let us do that now. We have to make some changes inside this build.gradle file itself. You will find all the information related to multi-dex inside in this page of the Android documentation. So here is the URL. On this page you will find all of the information that you need related to the multi-dex support. And here you will find the option, find the instructions to fix this, to configure the support for multi-dex in your app. So here we have to add this line in the default config section of the build.gradle file. So copy this line and come back to Android Studio, and here inside this folder Android, inside app, we have this build.gradle. Open this file. This is already opened here, and here in this default config section paste this line. So multi-dex enabled, true, and we have to add one more line in this dependencies section. Come back to this page again and copy this line and paste it here in the dependencies section. Now save this and run the app again. Now this time we didn't get those errors and our app appeared here. So our code executed properly without any error, and here we have the app, but this time we are getting an error from Cloud Firestore. And if you take a look at this message here, the caller does not have permission to execute this specified operation. This is related to the security rules. As I have mentioned earlier, while creating the database, we had two options, one to start in production mode and another to start in test mode. So now we are going to change the security rule to allow the authenticated users to access the database. So let's go over to the Firebase console, to the page of our Firebase project. So here is our Firebase project, and here we have this option, Firebase database, Firestore database. So click here and you will find this tab, rules. Click on this, and now here we can edit the rules. If you have not implemented authentication yet, return true from this. So add true here instead of false. Now save the changes, and this should work. You should see the list of, your app should be able to access Firestore. So in my case, as I have implemented authentication, here I am going to check whether request.auth is equal to null or not. Request.auth. If it is not null, this means that the user is authenticated, and then we are going to allow read as well as write. So here you notice this syntax, read, write, and then we have this option to specify the condition. If you pass true here, then read, write both are allowed without any condition. And if you add false here, which was the default option, which was added by default, so that will prevent from reading and writing regardless of the condition. So, and now here I am specifying this condition, request.auth is not equal to null. So if the user is authenticated, then only he or she will be read and write to this database. Now click on this button, publish here. Now come back to the app, and you will need to refresh the page, as we don't have a refresh button. Close the app and open it again, and here this time finally we have the item from the database displayed here. So notice this text here, milk. The only item that we have on the database is being displayed here. Now you can try adding more items on the database and see whether they get displayed on the list or not. Now here I have opened the Cloud Firestore database and the app side by side, and as we are using a StreamBuilder, if we make any changes here, the changes should immediately get reflected in our app. So let us try to add a new document. Let's create the ID automatically and let's add the field name, and this time let's specify the value for the name of the shopping item. Let's add a laptop. Quantity 1. Now let's click on the button save and notice here, and the newly added item got appeared here automatically. You can, if you make any changes here on this, on the individual documents, those two will get reflected on the UI on the page immediately. So here we cannot make changes to this quantity because we are not displaying it here. Let's try to make changes to this, to the name of the item. Let's make it capital and save the changes, and here notice the change. So this is the advantage of using a StreamBuilder instead of using a Feature Builder. Well, you can use a StreamBuilder only if you have a stream of data. So in this case, we had a stream of data provided by the Firebase collection reference class. So we have used it, and thus we are being able to listen to the real-time changes of our Firestore database. So with this, we have successfully fetched the data from our Firestore database. We have learned how to store data on Firestore, and we have also learned how to access those data and display on the UI. Next, we are going to learn how to add data on the Firestore database. So we are going to display a form on clicking this button to add a new shopping item to this shopping list.